So, welcome back. Next here is Arnold Bechtoldt talking about bootstrapping virtual infrastructure using OpenNebula. I'm a little bit sorry that a lot of guys visit the Ceph talk on the other side. But anyways, the people are here. That's your audience.
Yeah, I'm myself also interested in Ceph. But it's okay.
So
the videos will be recorded.
We record and give you the slides afterwards.
Of course.
Okay. So it's your stage. Thank you.
So, yeah, hello, I'm Arnold from inovex. Thanks for having me. I would like to talk about bootstrapping OpenNebula, or how to use OpenNebula with Foreman and SaltStack. Yeah, the Wi-Fi network asks me to authorize. A few words about me. I'm Arnold, working at inovex. We are busy with creating open source data center management solutions, and one of our jobs is to build high available web-based applications and services. Yeah. I'm myself also contributing to various open source projects. You will find some patches from me at the OpenNebula project and others. And yeah, but let's go to the interesting part. We had a project, a small reference project to test OpenNebula, to see what is possible with OpenNebula. And one goal was to set up a lightweight hosting platform running web applications. Let's take an average Java stack application with Tomcat, Apache, or something like PHP-based systems running an MySQL database backend and others. And one of our goals was to use the hardware resources more efficient. So virtual machines should be used instead of bare metal, and the infrastructure should be easy to maintain. When I speak about infrastructure, I mean the cloud infrastructure, the systems necessary to maintain the cloud, but also the infrastructure necessary to maintain, to run these hosting platform, for example, an average DNS server, DHCP, time, configuration management systems, taking the job of configuration management and others. And as I said, we hope no one died. Our job was we created a new infrastructure from scratch, so no existing setups, systems were available. And instead of using predefined or prepared disk images, which you can see on or read about in the OpenNebula documentation, but also in the OpenStack ecosystem, you often see virtual machine images which will be prepared. Operating system will be installed in a VM. Software will be installed, configured, and people make images from them and using them to bootstrap or to deploy additional virtual machines, for example, to scale the worker nodes for a service in no time. About this topic, I will say some words later. Another point was that no shared storage was available. This is a very funny thing when you want to set up high available applications, services. You need to take care of the availability and reliability of the virtual machines. And yeah, it was an interesting challenge. Also, the hardware, there were that was quite good hardware, but very medium-sized. they only had two 1 gigabit Ethernet network interface controllers, and normally when you want very cool cloud computing, you might want to have something like Ceph or other tools, and they have they have their hardware requirements, and with the hardware it wasn't possible. But the whole project here was to learn why what is OpenNebula capable of, and yeah. A few words about the architecture. You see the original cloud of the old days, the internet, having access to systems in these in this picture. You see, for example, that the Wi-Fi already again asks me to authorize. We simply disable the Wi-Fi chip. Three, two, one. You see management hosts running services used for the management infrastructure, for example, software like Foreman, your DNS server, for example, a bind DNS server, your DHCP servers, your systems you're using for configuration management, for example, the SaltStack master. When you're using Puppet, you would deploy a Puppet master here, and other things. Also the OpenNebula system itself, the OpenNebula controller, maybe the front end, user interface, and so on. And you see these hosts, well, there are these two management hosts, but also two additional hosts. In fact, there are more than two, but that's just for simplicity. They're all having using the same hardware. They all run virtual machines and having a very similar stack. So, for example, you have the local storage. There are only 4 hard disks running in a RAID 10 hardware RAID. For networking, OpenVSwitch was used to provide network connectivity within VLAN, virtual networks, virtual LANs across multiple compute nodes. Because of the fact that the switches, the whole switching infrastructure was owned by the ISP, and administration of the switches wasn't possible. OpenVSwitch was used for configuration management, but also the remote execution and some portions of orchestration. The tool SaltStack was used, or the stack. It does a lot more than SaltStack and remote execution. And as you might know, OpenNebula for virtual machine management. Right. How does VM deployment look like? You have these 3 columns here. OpenNebula used for virtual machine management, Foreman to do provisioning or do network-based installations of the hosts. These hosts can be bare metal hosts or virtual machines or other things capable of Pixie boot and something like that. And Foreman is also used as the external node classifier for SaltStack, which is also used by Puppet. Puppet and Foreman also work very well. And in the third column you have SaltStack, which is used to configuration management and orchestration. So how does the cycle look like? At the first point you have the VM creation. Let's say we create the virtual machine in OpenNebula via the Sunstone user interface or the command line interface or one of the application program interfaces or the API. And After that, you have the possibility of the hooks in OpenNebula to tell OpenNebula to create a host in Foreman. This works via the REST API of Foreman. It is very easy to deploy or to create new hosts in Foreman, changing the host parameters of hosts, adding subnets or managing subnets and things like that. And the API is very cool and very well documented. So you have this hook creating the host in Foreman. What Foreman does is adding the DHCP record. Let me say that OpenNebula uses the Foreman API and tells OpenNebula Foreman to the host name of the virtual machine, the domain name, the IP address, or the subnet. Foreman can choose then the IP address based on the available DHCP records or the used DHCP leases. And that's it. And what Foreman now does is to add a DHCP record so that the system might be, regardless of if it is a virtual machine or a bare metal, plain hardware, can boot via the network, via Pixie Boot, and downloads the TFTP files from CentOS or from Debian to start the network-based operating system installer. Yeah, Foreman also does downloading these TFTP files when they're missing, and some additional magic. And when the network installation starts, the network installer calls Foreman for the preset configuration, or CentOS side or Red Hat side, the configuration of Anaconda called Kickstart. These information contain all these configurations contain all data and information. For example, for the partition table layout, which additional packages should be installed, which default root password should be used, and so on. You might have worked with it. This is not any rocket science. So this installation proceeds in step 4, and you might have as finish or post-installation task some lines doing some additional bash or shell magic, where you say, install me additional packages, or for example, install me a Puppet agent or a Salt minion, which is the agent software at SaltStack, and the system reboots. And now the SaltStack part is SaltStack is now taking part of the additional process. You have starting the virtual machine after the first reboot, after the installation, and SaltStack will then take care of doing installing software, configuring software, and for example, you have seen it from June, installation of a compute node, the software, adding any sources and so on, and all things you can do with configuration management. And then you can do some magic of orchestration. So for example, adding additional hosts after the system has been installed. You can add this host, if it's a bare metal system, to an OpenNebula cluster or something, or adding the machine to as additional web backend to a software firewall or something. All things that can be understood by orchestration. And the additional point is you can then let SaltStack, maybe in work with OpenNebula itself, do additional scaling, for example, deploying additional virtual machines. That would be possible out of the within the SaltStack process, Yeah, but it depends whether you want to do scaling with SaltStack or with OpenNebula. Depends always on your project and your requirements. There were some interesting challenges. For example, because the hardware, the fact that the hardware is very limited to, or we are very limited to do the administration of the switches, the hardware switches, and not having any physical access to the systems. So one cool thing was to not having any shared storage. We decided to use the QCode2 VM images. When you prepare QCode images on your controller or on your system, having the whole operating system data in this image, and want to transfer the file during the virtual machine deployment to the target compute node, you will, using the SSH transfer manager, you will have OpenNebula copy the whole file, because QCode file images don't need to allocate the whole size. For example, I'm saying I'm creating with qemo minus emg, creating a new image file, a QCode file, and say, so you can grow up to 250 gigabytes, but only allocate metadata and something like that. Yeah, and when you're using the SSH driver, the whole file will be transferred to the target host, and you don't want that. What we have done is modifying the transfer manager, which is based on the SSH driver. We're simply creating a new image on the target host without copying from the controller, and that's it. Right, that's it for the storage part. The networking part was also very interesting. From my part, I'm not my sources aren't from the networking branch or area. I set up, created the Open vSwitch networking stack, or I implemented it using Open vSwitch. And since I'm not having a lot of experience with IP, have very low cloud infrastructure requirements. That's thanks to the OpenNebula concept. You only have your compute nodes, your OpenNebula controller, and that's it. You can scale at the user interface level, and I don't have experience in scaling the OpenNebula controller, but I think that should be also possible. At least it should be, or it is possible to make it higher available in an active passive setup. Thanks to the SaltStack part, it is possible to implement a very high degree of automation. So, like when you're using Puppet, you can deploy new hosts using the process, the cycler I showed here on the other slide. You can deploy new hosts when you have prepared your Puppet files, manifests, or your SaltStack files, and everything is done fully automatically, so you don't have to do anything to install software, changing configuration, default configuration, and things like that. you have, thanks to OpenNebula and OpenVSwitch part, you have a very cloud-like feature set. I'm careful saying cloud because the scaling, the horizontal scaling, isn't tested in the setup. There are only 5 up to 10 compute nodes. Things may look different when you're adding 40, 50 or other additional compute nodes. There might be some limitations at the GRE level. Because of the shared storage, you don't have availability of doing live migration of virtual machines when you're maintaining a compute node or something like that, or you're having a crash and want to spawn the virtual machine on a working other node. You have to choose other ways to make your services high available. Right, and the VM deployment using the way of provisioning and deploying by net install takes up to 10 minutes. For some people having the requirement of deploying new additional systems, this can be too long. I also wrote some thoughts or ideas at the bottom here. It always depends what you are choosing for your setup, whether you are using the prepared virtual machine images to do fast deployment of additional virtual machines in your private or your public cloud, or you're using individual deployment and network-based installations, so you don't have to maintain these visual images because they should be always having current state of the package versions and so on. You can also decide whether you're using DHCP or the OpenNebula contextualization. You can move some logic to Foreman or SaltStack regarding the IP address management when you have Foreman integrated in your CMDB or other parts in your corporate infrastructure. And cats aren't always bad. I would say that the virtual machines in the setup are more to see as pet kettles, because they have, some of them have a very long lifetime, because they're providing a long time to provide to server service, web services. But OpenNebula can be used to maintain or to run these systems, these long living machines, and pets aren't always bad, but all of them have the advantages and disadvantages. This was my last slide. If you're interested, we are hiring in Germany. We are having a lot of excellent job offers, and want to thank you to listening, although there's another talk about that which is also very interesting. Thank you. So if there's any questions, feel free.
Some questions? We don't need the microphone because it's broken.
So what's more or less the size of the Nebula deployment we're talking about?
We're talking about 5 to 10. It's 8 or something. I don't have the right numbers. Talking about from 2 to 300 virtual machines running on these nodes.
Did you beat any bottleneck?
No, I heard of bottlenecks in the monitoring part of OpenNebula. I must say that monitoring of virtual machine is done by other systems like Nagios, Check-and-Car or other tools. I don't saw any production critical bottlenecks, but the system is, as I said, more a lab than running big production load.
Why do you use the API of Foreman and not the API in the other direction, the API of OpenNebula with Fog, for example, which is now implemented in...
Thanks to the NetBase guys, there is an OpenNebula plugin in Foreman. Unfortunately, it is at the moment not compatible with the current OpenNebula or Foreman version, but I tend to say that I'm using Sunstone more as the interface for the customers or for the users instead of Foreman. In Foreman you can add additional hosts, and Foreman could manage these. There are also other providers for Oviet, vSphere, EC2, OpenStack, and so on. But Foreman is used or is especially perfect for admin guys, and I think the Sunstone has some, next to the fact that it is very fancy and looking cool, it has a very high level user interface which could be suitable for your customers. And thanks to the features of OpenNebula, you can use the hooks to do additional triggering additional processes like adding a host in Foreman, or adding a host in your configuration management database, or triggering your accounting, billing, or something. Questions?
How is your network latency between your hosts when you are running the creator now and IPsec on top of it?
The networking part, as I said, the networking part was very interesting and funny, and cost a lot of cups of coffee. I made some tests using iPerf, which is just using very small packets, not writing to the disk. As I said, the network interface controllers had a bandwidth of 1 gigabit, and when you're running the iPerf tests between compute nodes or between compute nodes and virtual machines on the same host or other hosts. For example, you're running the iPerf test on the compute nodes to the virtual machine on the same system. You just have something like 19 gigabit. It's far more as the Linux bridge itself. When you're running the iPerf test to another virtual machine in your network, to another compute node, you can use at least the gigabit bandwidth of the host. So gigabit wasn't a big problem. When you're using 10 gigabit interface controllers, that might look different, but I couldn't find any bottlenecks in the networking part because there are only 1 gigabit interface controllers.
Thanks again, Arnold.